In this video, we're going to remember what the least common denominator is for a pair of fractions in preparation for us doing question 3 in homework 7.3. So remember that the least common denominator is that so-called smart denominator to choose, so that there's less work in terms of simplifying or reducing your fraction after you've gone ahead and done the addition or subtraction. That least common denominator is the least common multiple of each denominators. So for an example, if I were to go ahead and subtract 5/12 from 1/18, I could, this is an option, I could multiply 5/12 by 1 in the form of 18 over 18, and I could multiply 18ths by 1 in the form of 12 over 12. And then I would have that common denominator of 12 times 18, because 12 times 18 is the same thing as 18 times 12. It is 216, right? This would give me a denominator of, what did we say, 212? Oh, 12 times 18, 216. But, and you could work with that, but it's not the least common denominator. Instead, if we went ahead and skip counted by each denominator, I'm going to skip count by 12s. And I'm going to skip count by 18. Twelve times 2 is 24, times 3 is 36. How about one more 12? 48. And if I skip count by 18s, 18 times 2 is 36. Oops, 36. That number is the smallest multiple that both 12 and 18 share. It's that least common multiple of each denominator. So it would be better to go ahead and have a denominator of 36. I'm going to do least common denominator is 36. And in this homework question, we just need to name what the LCD is, but the reason, why do you care? Why care? Is because if I were to do this problem, it would be better to have that denominator of 36. It would be less work. So I would multiply by 12 in the form of, multiply 5/12 by 1 in the form of 3 over 3, and 1/18, multiply it by 1 in the form of 2 over 2, and now I've got the denominators are 36, that LCD, and this just makes my life easier. I'm not going to go ahead and do these problems, or really the same problem twice, but this is a vastly more efficient way to go ahead and do the problem. Okay. So now let's go ahead and do problem number 3. Actually, before we do that problem, I want to show you guys another way other than skip counting for how to find that least common denominator. So if I take the denominators of 12 and 18 and go ahead and factor them completely, meaning getting them into a product of their primes, 12 is 2 times 6, and 6 is 2 times 3. So when we factor 12 completely, 12 is 2 times 2 times 3. 18 is 2 times 9, and 9 is 3 times 3. So when we factor 18 completely, it's 2 times 3 times 3. Looking at these, I see that they both already have 2 as a factor and 3 as a factor. I don't need to double count that. So one way to go ahead and see the least common multiple here, a Venn diagram is kind of fun. 12 is 2 times 2 times 3, and 18 is 2 times 3 times 3. Yeah? 12 is 2 times 2 times 3, 2 times 2 times 3. 18 is 2 times 3 times 3, 2 times 3 times 3. So here I've removed that repetition of them each having a 2 and each having a 3 factor in them. Right here is my least common multiple between 12 and 18. It's that least common denominator. My LCD here is 2 times 2 times 3 times 3, which is 4 times 9, which is, oh my goodness, 36. Yeah? Now, I understand that that's probably a little bit more work than just doing the skip counting, but it's more applicable for when we're dealing with rational expressions. I want to factor things completely, and then there's no need to double count a common factor. Okay, so now let's go ahead and do number 3. Find the least common denominator between these two fractions. So to do that, all I need to do is look at each denominator. I don't even care what the numerators are. And I'm going to factor each denominator completely. Right? This is like the 12 and the 18. All right? So I'm going to factor each denominator. X squared plus x minus 6. My leading coefficient is a 1. I love that game. I know this much of the story. And now I'm looking for two things that multiply together to give me negative 6 and add up together to give me positive 1. That is a minus, two things that multiply together to give you negative 6. So we've got a 3 and a 2, and I want my 2 to be negative. Minus 2 minus 3. Minus 3x minus 2x. Oh my goodness, your teacher is sleepy. A negative times a negative is not a negative. I want that 3 to be positive. Positive 3x minus 2x is positive 1x. Delightful. And minus 2 times positive 3 is negative 6. So green is green, and then blue, x squared plus 4x plus 3. Again, that leading coefficient is a 1. I know this much of my story. Two things that multiply together to give you positive 3 and add up to positive 4 are a positive 1 and a positive 3. Blue is blue. Okay? So notice that they each have an x plus 3 factor in them. Right? So no need to double count them. The least common, but their green is missing an x plus 1 factor. I need one x plus 1. How about dark blue? I need one of those. And the blue is missing this x plus 2 factor. Right? So I need one green, one red, and one blue. If this is helpful. Yeah, if you wanted to, just for fun, you could do your little Venn diagram. Make it a little bigger. X squared plus x minus 6 factored into an x minus 2 times an x plus 3. There's my green. Those things multiplied together. And my blue, x squared plus 4x plus 3, factored into x plus 1 times x plus 3. So I've already got an x plus 3 right there. I'm missing an x plus 1. Blue is blue, right? So my LCD, and it's fine to leave this in factored form. You could multiply it out, but it's less useful. Here is my answer, and I'm going to go ahead and just put it into my into my computer in factored form. Let's go ahead and do that. Coming into my answer field, I'm just going to insert parentheses. X minus 2, close those parentheses. X plus 3, close those parentheses. And x plus 1, close those parentheses. And it should read that implied multiplication. It's saying that it can read it. Let's go, and that's exactly what I want it to look like. Let's hit submit, see how we did. Beautiful! We did it great. You could multiply all this stuff out, but you don't want to, because the whole point is for us to go ahead and add or subtract these fractions. We just found the smart common denominator, the least common denominator between these two fractions.